Welcome back, Matadors. We are now in Chapter 2, Lesson 2 on translations. This is going to be the first geometric transformation that we go over. So first off, I just want to draw your attention to the two short videos that you see up on the screen. You see that on the left-hand side of the video, that kid's having the time of his life. Back in the days when people used to play outside, right? What is he on? Look at that face, just completely full of joy. What is he on? It's kind of a homemade one. We used to do it back in the days. Put some Johnson & Johnson baby shampoo on it. You can slide a little faster. That's like the ultimate slip and slide, right? That's the ultimate slip and slide. And on the video on the right, what kind of dance are they doing? Well, they're trying to do the electric slide, right? That's probably what I would look like, trying to do the electric slide. But what do those two pictures have in common? If you guess the word slide, you're absolutely correct. So these two images, and what they have in common is the word and the action, right? Slide. And that's going to be kind of the word of the day. The geometric transformation, translation, can be best described in one word as slide, because you're basically taking a shape and you're sliding it somewhere onto the coordinate plane into another position. So slide is the key word. Slip and slide, right? There he goes. The essential question: how can you arrange tiles to make a tessellation? Okay, tessellation is just a fancy math word for repeated pattern of polygons. So all that word tessellation means is that you are repeating some type of pattern for a given polygon. And if you look at the tile pattern, that looks like some old school 1970s linoleum kitchen floor. Ask your parents, they could probably confirm what I'm talking about. But all it is, if you look to the right, is it's basically this light bulb looking shape repeated, right, over and over and over again. And the way that they're able to repeat it is through what's called a tessellation. And in an even more elementary sense, it's a geometric transformation called a translation, which is where you take an image and you slide it. So the pattern is repeated because the shapes are translated. When you take a shape and slide it from one place to another, you're doing what's called a translation. Moving on. So a transformation changes a figure into another figure. The new figure is called the image. So you move it from one place to another. That second image, that second place, that end product is called the image. So this is where the image is where you finish. Okay, where you end up with. A translation is a transformation in which a figure slides. That's the key word, right? Word of the day. Slides, but does not turn. It does not turn. There is no turning of the shape. Do not turn the shape. If you do, you're not doing a translation. Every point of the figure moves the same distance and in the same direction. So if you look, there are two right trapezoids. Trapezoid A, trapezoid B. Trapezoid A is where you start. It's slid, or it's performed a translation over to the right, in the right direction. So A is where you start, B is where you finish. The shape for B would be called the what? The image, right? Because this is where you moved it. There is no rotation, and the shape does not change its size. Okay? So we slid the shape to the right. From A, the pre-image, to B, the image. Okay? And again, you can rewatch this section at whatever pace you'd like. I'm going to move on for the sake of time. So let's do a quick check. Okay, keeping in mind the keyword, right? Slide. You have two sets of shapes on the left-hand side, so let's focus our attention here. You have a blue trapezoid and a red trapezoid. Let's say the blue is the pre-image and the red is the image. In other words, we went from this shape here to this shape there. Is it a translation? Why or why not? Well, if you look at the shape, it was simply what? Slid down and to the right. So this is a translation. So yes, because the action, right? Yes, the action was a slide. That is a translation. So let's take a look at our next set of shapes. We have two rectangles. And again, let's go with the blue being the pre, so this is where you start. The red being the image, so this is where you finish. Is this a translation? What do you notice happened? Well, it looks like the shape turned, right? It was a rotation. It turned. So because it turned, this is not a translation. So because it turned, it is not a translation. So on the left, yes. On the right, no. Moving on. So here's a key idea. So when you're making translations onto a coordinate plane, right? Remember, the coordinate plane is just the x-axis, the y-axis on a grid. Nod your head for me. Yes or no? Thank you. To translate a figure, now we're going to give it a certain amount of units to describe its translation. So a units horizontally. Horizontally has to do with which axis? The x. So the A in this case is going to tell you how we're going to move it along the x-axis. And B units vertically. Let's do this in blue. B units vertically. That's the y-axis. So however many units it tells us to move it for B, that's going to be pertaining to the y-axis. So how many units are we going to move the shape up or down? In a coordinate plane, we're going to add A to the x. So we're going to add A to the x coordinates, and we're going to add B to the y coordinates. Now remember, if they're positive, right? If they're positive, you're going to either move up or to the right, because those are both positive parts of the number lines, right, of the coordinate plane. If you're moving it negative, then you would move it to the left, right, or down. And you'll see what that means in a second. Positive values of A and B translate up and to the right. Negative values of A and B represent translations down and left. So here's the algebra of performing translations. You take your original coordinate or ordered pair, and you're going to add a certain amount to it to get its new location along the x-axis, and you're going to add this amount to it to get its new location along the y-axis. So let's see if we can make sense of that looking at our red and blue triangles. Now, I want to draw your attention real quick to these little hash marks here. Okay, that little hash mark means that that's the image of the shape. In other words, that's where you moved it to. So in red, okay, that shape is where you start. And in blue, this shape is where you finish, right? This is the image. In other words, this is where you moved it to. And this is the pre-image. This is where you start, okay? Now let's go ahead and let's see if we can figure out mathematically how to describe this translation. Well, let's just take the first, let's take the B's. Okay, well, let's take these B's here. We're going to go from this B to this B. How do we do that? Well, first let's count how many units to the right. That is 1, 2, 3, 4 units to the right. So since we're moving to the right, it's what? Plus 4. And now we're moving down. So how many units down? 1, 2, 3. So down means negative 3. So for coordinate B, originally, let me draw your attention here. Originally, it's at negative 1 and positive 4. To the X, we added 4. To the Y, what did we do? We subtracted 3. And where do we end up? Well, what is negative 1 plus 4? That's 3. What is 4 minus 3? That's 1. Okay? And you could do the same movements to all the other points to move them or translate them or slide them to their new shape. So it's to the right 4 and down 3. Let's look at A. And let's count. How many over? 1, 2, 3, 4. So that's to the right 4. And how many down? 1, 2, 3. Noticing a pattern? Let's take a look at C. 1, 2, 3, 4. And 1, 2, 3. So that's how you perform a slide. And that's the end of our note.